Hello everyone. In this video, we're diving into one of the most beautiful and powerful ideas in linear algebra, orthogonality. It's the mathematical foundation behind PCA, embeddings, and so many components in ML. So what exactly does it mean when two vectors are orthogonal? And why is this concept so important for understanding data and models? So let's find out. We'll start with a simple concept. Two vectors are said to be orthogonal when they are perpendicular or at a 90-degree angle to each other. In geometry, that's like the x and y axis, perfectly independent directions. Mathematically, we say that two vectors a and b are orthogonal when their dot product is 0. That's it. No overlap in direction, complete independence. Imagine standing at the origin of a 2D plane. One vector points towards its east and then the other vectors point towards north. They're pointing in opposite direction or different directions. They don't interfere with each other. That's orthogonality in its purest form. The dot product of the formula says a dot b equals to the magnitude of a multiplied by the magnitude of b cos theta. If the dot product is 0, that means cos theta equals to 0 and theta equals 90 degree. That's why we say that orthogonality represents the perpendicular property of these two vectors. But here is where it gets interesting. Orthogonality just doesn't mean perpendicular. It means independent. If two vectors are orthogonal, changing one has no effect on the other. That's why in data and ML, we love orthogonal vectors. They represent uncorrelated information. But why does this matter in machine learning? We'll look at a few key reasons. In principal component analysis or PCA, so PCA basically finds a new axis, new directions that are orthogonal to each other. Each axis captures unique variance in the data without overlapping information. In case of neural network, orthogonal weight initialization ensures that the signals don't explode or vanish during training. It keeps the information flow stable. And in feature engineering, when features are orthogonal or uncorrelated, models learn faster and perform better because each feature contributes new information. Now let's look at orthogonality one step higher. Two matrices. An orthogonal matrix is one whose transpose is its inverse. For example, Q transpose Q equals to I. Geometrically, that means multiplying by Q doesn't stretch or skew your data, it just rotates it. And also, the length of every vector stays the same. That's why orthogonal transformations are used everywhere. In PCA, in rotations, in normalization, and even in graphics. They're shape preserving transformations. So to summarize, orthogonal vectors represent perpendicularity and they also represent independent directions. Dot product equals to 0 represent no overlap in information. Orthogonal matrices preserve length and angles and they are perfect for rotations and PCA. And especially in machine learning, it helps us keep features uncorrelated and transformations stable. So, next time you see orthogonal vectors or orthogonal components in a ML algorithm, remember it's not just math jargon. It's about cleanly separating information into independent and stable directions. And that's orthogonality. Simple, elegant, and incredibly powerful. So if you enjoyed this explanation, hit that like button and subscribe for more videos in our Math for Machine Learning series. I'll see you in the next one.